All right, guys, here we go. Lesson number 6, roots of perfect powers. Now, perfect powers are supposed to be things where, like, when you take the square root or cubed root or fourth root, the actual roots, the square roots, the cubed roots, those things disappear. Some people like to call them the little houses. But yeah, that goes away. Okay, so the radical symbol will disappear. Now, there's a couple things we have to talk about first. Okay, whenever we think about radicals, okay, a lot of people will see it kind of like this: n, and then the radical, then x to the p. Now, just so you know, n, this is called the index. Okay, so normally they'll put a number there. So they'll put a 3 for the n if it's a cubed root, a 4 if it's a fourth root. Now, if you don't see the letter n, that means it's a square root. Okay, so I'm just going to put right here. If you don't see it, then it is a square root, because a lot of times for the square root they don't want to write the number 2 in the front. That's just not something they've done, so they don't do it. Okay, the x, this is called the radicand. So the radicand, in other words, the thing inside the radical. And then p is the power. Okay, so this is the power. Now, they call these perfect powers because this could happen, okay, if n equals p. Okay, so if the n equals to the p, then the radical disappears. Okay, so the radical disappears. So let me just give you a for example type of thing. If they had a cubed root of 2 to the third, then you'll notice that the cubed root and this power of 3 are the same. So the radical is just going to disappear and your answer will be 2. Okay, everything disappears and just the 2 remains. Okay, so that's what they mean by if n equals p. Okay, now we do want to recall a couple of things. Now, I know we've talked about this before, but we want to recall some properties, okay, or at least one main property, which is if you have x to the m to the nth power, then that's called the powers of powers. That's what that's called, the property. It's called powers of powers. So if you have a power of a power, then you get x to the m times n. You multiply the powers together. Okay, so just to give you a little example of that, if you had x to the second to the fourth, then that'd be x to the eighth. All right, and one more thing before we start getting into this. Actually, maybe two more things. But one main idea first. If the index is an even number, okay, so let me highlight that. So if it's an even number, then you get a plus or minus answer. Okay, so that's if the index is an even number, then you get a plus or minus answer. If the index is an odd number, so an odd number, then you get one answer. Then you get one answer. Okay, now like I said, a couple little things here. An even index, so an even index cannot, all right, so cannot, so an even index cannot have a negative radicand. Okay, so in other words, this cannot be done. The fourth root of negative, let's say 64. Okay, this is not a real solution. Okay, that cannot happen. You cannot have a negative inside of an even number index. Okay, so even, so you guys see that right there? There's your even index. So you cannot have that. Okay, now if it's an odd index, you can have negative radicands. So an odd index can have negative radicands. All right, so something like this, the cubed root of a negative 27 is a negative 3, because negative 3 times negative 3 times negative 3 is negative 27. Okay, so that can happen. All right, so one last thing before we get to this, or actually let me just review really quick with you guys. So n to the radical of x to the p, remember n is called the index, the x portion is called the radicand, the p is called the power. If the power and the index are equal, then the radicand disappears. This recall portion right here, if you have a power to a power, then remember it's a product. So a power to a power is a product. It's 3 p's in a row. Power to a power is a product. And then these situations, if the index is an even number, then you should get a plus or minus answer. So you get 2 solutions. But if the index is odd, then you only get 1. And then if you have an even index, you cannot have a negative radicand. But if you have an odd index, okay, so you have an odd index, then you can have a negative radical, negative radicands, okay? So the last thing, which is something you guys should all know, okay, are the radicals. So I'm just going to write them out real quick. So radical 1 is 1. Radical 4, that's 2. Radical 9, and I know you might be saying, well, I already know this. Well, hey, there's always somebody who doesn't remember, right? So, we're going to do it for them. So this will be 5. Radical 36 is 6. Radical 49 is 7. Radical 64 is 8. Radical, is it 81, is 9. Radical 100 is 10. Radical 121 is 11. Radical 144 is 12. For 13 is 169. That's 13. For 14 it's 196. For 15 it's 225. Let me rewrite that 5 again. And the last one is 256. That's 16. So you guys should know those, okay? You should know those. So from 1 through 16, you should know those square roots, okay? So here we go. Let's talk about the things they're expecting you to be able to do. And some of this stuff is going to seem super easy, so that's good. Some of this might seem a little bit more complicated, but I don't think any of it will classify as super difficult, okay? So here we go. They want us to simplify. Okay, so part A. We'll take the 4th root of x to the 4. Now notice, for this one, the index matches the power. So according to the definition, your answer should just be x, because the radicand is just going to disappear. So that's the first one. B. The cubed root of 2x plus 1 cubed. Again, the radicand and the power match. So the only thing that's left for us to write down, because it's gonna make the radical disappear, is just 2x plus 1. So there you go. We have our answers. Okay, those are pretty quick, and yeah, some of your homework will literally be that easy, so that's good, right? So those are two examples. Okay, now they will give you some other stuff that might be like trick questions. So they might say like, what is the square root of negative 25? Well, notice the square root, that means that the number there is a 2. That means that you have an even index. And if you have an even index, you cannot have a negative radicand. Okay, so right here you're going to put not a real solution. Okay, so not a real solution. So we'll just put that and we're done. All right, and part D, if I put the cubed root of 8 over 125, well, I just got to think to myself, what number times itself 3 times makes an 8? Okay, what number times itself 3 times makes an 8? Well, I know 2 times 2 times 2 is 8, so that would be a 2. And then what number times itself makes 125? That would be 5. So there's my answer for that. Okay, so 2/5. All right, so great. No big deal, no problem. So let's go to this next part. Okay, and then we're going to be done. So this will be pretty quick. Example number 2. They're going to say, what two numbers is the square root of 50 between? Okay, let's call that part A. All right, let me rewrite it like this. I'm going to kind of copy it and see if I can place it a little lower here. So we'll cut it and we'll put it right here. Okay, so part A, what two numbers is square root of 150 between? Sorry, square root of 50 between. So this is what I think. Okay, I don't know the square root of 50, but surrounding 50, if I come back up here, 50 would be somewhere between these two numbers. Okay, the square root of 49 and the square root of 64. Okay, so I know that the square root of 49 is less than the square root of 50, which is less than the square root of 64. Okay, like I said, it's right here. Okay, 49 and 64. So square root of 50 would be right in between there. Well, all I got to do is say, okay, the square root of 49 is 7, and the square root of 64 is 8. So when they ask us what two numbers is the square root of 50 between, the numbers are 7 and 8. Okay, let me rewrite that a little nicer here. 7 and 8. Okay, so that's the first one. Okay, so what two numbers is the square root of 50 between? Between 7 and 8. Now, last one here, same instructions. What two numbers is the square root of 13 between? Okay, so I'm going to go back up to my list. The square root of 13, I know I don't know that, but I know that 13 is in between those two numbers, square root of 9 and square root of 16. Okay, so square root of 9 and square root of 16. That's where square root of 13 is between. Okay, square root of 13 is between the square root of 16 and the square root of 9. So the square root of 9 is 3, and the square root of 16 is 4. So that means that the square root of 13 is between 3 and 4. And that would be your answer for that problem. So that's what your lesson 6 is going to be like. So hopefully it doesn't seem too difficult for you guys. And again, make sure you guys tell your teachers if you need help. Don't just leave us wondering how things are going, okay? So have a good day.